All right, Brad, can you hear us yet? All right. Well, how about this, Elli? I don't want to butcher your appointment at the university. So can you tell us a little bit about what your appointment is at the university, and then you can start into your discussion this morning.
Sure. So I'm an assistant professor in the School of Earth, Environment, and Society at McMaster University. I'm also the Fairley Gadsby Research Chair in Fluvial Geomorphology. So a lot of my research and teaching is around fluvial geomorphology, sediment transport, river restoration, all of those themes. So that's, I guess, a little bit about me.
Great. Well, thanks for joining us today. And then you'll be presenting today. Do you have a presentation to share, or will you just be kind of talking off the screen, or what's your
I do have like a PowerPoint to share, so I can share my screen if that works.
That sounds great. Thank you, Elli.
Oops. Can everyone see my screen?
Yep, we can see it just fine. Thank you.
Perfect. Should I just get started, or are we waiting a couple minutes for people to trickle in?
Let's get started.
Okay.
That way we can be respectful of people's time that are on the line today. Brad, do you have anything else to add? You had a little bit of connection issues, so we just introduced Elli without you, but if you have anything else.
Yeah, sorry, I'm having trouble with my Zoom connections lately. So anyway, I just got in. So I'll assume you did a fine job, and we'll move on. Let Elli speak. I'm sure people want to hear her a lot more than me.
Sure. Okay. So today I'm going to talk about a project that is currently still ongoing. It has been ongoing for a little bit of time. It's all about using a scaled model to assess the performance of the Penticton Creek Restoration Project, which is a project in British Columbia, Canada. You'll notice there's a lot of authors on this presentation. That's because there's a lot of people who've contributed to this project in a lot of different ways. So currently I'm at McMaster University. However, this project is in collaboration with the University of British Columbia, as well as the University of Waterloo, who's actually where we've hosted the experiments. It's also in collaboration with a team of Stantec that's in British Columbia, and it's funded through a program called MyTax, which here in Canada facilitates projects that link industry and academia, so you can get funding to do joint projects together. And a lot of the legwork has been done by myself, but also many students. So I wanted to sort of share appreciation for them. They've really been the boots on the ground. And one of my students is actually on the call as well. So it's nice to see the students getting something out of it as well. So to get started, Penticton Creek is in the interior of British Columbia. You can see it on the map on the left-hand side. It's quite south, so it's pretty close to the border with Washington. And Penticton Creek drains into a lake, and this is sort of showing its watershed on the right-hand side. It's not too large, but what's important is that it flows through the city of Penticton, and that's where they've had a lot of issues with flooding, and there's a lot of ongoing restoration work being done there. So a little bit of history. There were two large floods in 1942 and 1948 that caused a lot of significant damage in the city, and that's what kicked off the need for restoration in this area. So back then, the creek was completely channelized, and it was just a concrete lining was installed, and it sort of stayed that way for many, many decades. The channel was also narrowed from 60 meters to about 6 meters wide at bankful. I'm sorry, all my units are going to be in meters, so I'm not sure how to translate that into feet. But the idea is that you can see it's significantly narrowed, and that was mostly done to accommodate things like roads and bridges and all the usual sort of things. Because it was narrowed, it was also made quite deep at the time. And essentially it was just a concrete drainage canal. So in 2017, the city of Penticton released their Penticton Creek Master Plan. They divided the channel into 13 reaches, at least a section that was through the city, and each reach was to be designed and restored as a separate section. And in 2015, they actually built a showcase reach. So kind of just to show an example, it's the one on the right here. This is what it looked like. You can see the concrete lining was removed. They've put in pretty rough material. And this was sort of just to show what it could look like. Since then, they've actually approved the restoration project. So the restoration project is now going ahead for the remaining of the reaches as well. And the main goals, as you can see here in the stated in the master plan, was to have flood protection, restore fish habitat, and sort of trying to find designs that can do both. So our focus for our experiments was mostly on the restoring fish habitat side, and I'll talk a little bit more about that. So the reach we were focusing on is called Reach 3A, the upper section, and also Reach 3B. So the purpose for this reach was to stabilize the channel with natural materials to mitigate flooding and improve fish habitat, and also to restore fish passage. So they wanted to remove the existing concrete and rubble. They wanted to remove an existing structure. There was sort of this spillway that had a fish ladder that wasn't very effective and was pretty severely damaged. They wanted to regrade the channel to contain the 200-year design flow, provide resiliency for up to that design year flow, introduce hydraulic controls and channel features to improve fish passage, habitat, and spawning. And that was really, again, the focus of our project. And then include vegetation for fish habitat and aesthetic benefits. So these are just showing their design flows. They went with the 200-year flow. They also had the maximum instantaneous discharge, but their design flow was the maximum daily design flow, which was 48 cubic meters per second. So what's interesting with the hydraulic controls to improve fish passage, habitat, and spawning, as part of that, their plan is to put in some spawning gravel, which would be sort of looser material that would be provided to the channel to provide some of that habitat. And they had a lot of questions around the stability of that spawning gravel and where the best placement would be to provide the most resiliency for it. So this is the design channel. You can see there's an upper section, which is quite steep. It's at 3.6%. So that's replacing that spillway or that feature that was there. So it's quite steep. It is a series of steps and pools there. Then it flows under the bridge into this really deep pool section. And then it flows into a lower section that's more of a classic riffle pool sequence. It's also at 2.1%, so still relatively steep. So our experiments focused on this lower section. This was also their focus for that fish spawning habitat, was this set of pools and riffles down here. This is what it looked like on the side. They had coarser material along the riffles that were designed to be stable. Then there was the pool. They added some roughness features as well in the pool. And really the question was, where can we best seed the spawning gravel that would best allow it to stay there and be stable during different flow conditions? And if that spawning gravel layer is mobile under high flows, how might it rearrange or redistribute in the channel during those flood events? So to answer some of those questions, they obviously did some modeling at the time, but we were interested in using physical experiments to see if we could validate some of those models and see if we could recreate some of those conditions. So we went with doing a set of flume experiments. So flume experiments are very popular in research. A lot of river hydraulics, sediment transport, geomorphology research is done with flumes. They're quite popular. Here's the picture of the one we used at the University of Waterloo. It's 1.2 meters wide and 15 meters long, so it's quite large. And it allows us to control a lot of variables very precisely that we wouldn't be able to otherwise in the field. So we can set our flow rate, we can feed sediment, we can measure our topography down to the millimeter scale, very detailed. So it allows us to sort of control and measure different aspects that might be more difficult to do in the field. There's obviously many sizes and types of flumes. The one we used recirculates water, so the water's pumped back through, but the sediment isn't pumped through. So any sediment that comes out the end is collected and weighed. So this photo here is showing pictures from a different set of experiments that have been done just to illustrate the types of data that we can collect. So we can collect really high resolution imagery. So in A, you can see that's a stitched together rectified image. And we actually use targets to place this in space and time. So we can take multiple photos and we can look at how the sediment is moving and redistributing through the channel. We can also take 3D images. So this figure here is showing topography. So the yellow areas are higher elevation than the purple. And again, we can do this at the millimeter scale using photogrammetry. So we have two cameras that take photos at a different angle, and then we can stitch those together in the computer and get really very precise three-dimensional models. We can also measure things like small scale hydraulic structures. We can get in there with instrumentation and measure our flow and our turbulence very precisely. And some people even plant plants in their flumes and study the effects of vegetation. So I've been to labs where they'll plant alfalfa or grass or something and look at how that might affect the flow as well. Some people might be wondering, how do we properly scale models to still tell us something about reality, even though it's much smaller? This is pretty interesting mathematical problem. So we usually use Froude scaling. There's a few different methods. I would say Froude scaling is the most popular by far. So it's a set of scaling relationships meant to present the fluid forces. So your Froude numbers, your shear stress, your shear velocity, all of those values are preserved, which is why they're popular for flume experiments, especially when we're interested in things like sediment transport. We want to make sure that those relationships are preserved even at smaller numbers. The one thing that Froude scaling does, though, unfortunately, is it does change your Reynolds numbers a little bit. You usually get slightly lower Reynolds numbers than you would in the field. So this is a small limitation. And again, models are simplifications of reality. So doing the best that we can. So this list here is showing an example of the scaling factors. So for example, your length is scaled to 1. So if you want to do a 1 to 30 scale, your length will just be 30 times smaller. So it's a pretty simple relationship. You'll notice things like density isn't scaled at all. So you use the same density of sediment in both cases. However, things like velocity and time are scaled to the square root. So you start getting much shorter experiments in the flume represent real life. And you have to keep in mind all these scaling factors as you design your experiments. So this is what our scaled model of the Penticton Creek project looked like. We scaled it to 1 to 30. So again, our length scale is 30 times smaller. So in real life, I guess the model is 141 meters long. Our scaled model is around 5 meters long. Our slope is preserved, but you'll notice the average bed width, our riffle spacing, and our pool depths are all scaled based on that 1 to 30. Our flow then is also scaled according to a Froude scaling, which isn't a 1-to-1. There's again a scaling relationship for discharge, but you can see the 2-year return flow in Penticton Creek's 11 cubic meters per second. In our case, we're working with 2.2 liters per second, so much smaller. And then finally, we also scaled our roughness and our sediment material. So the sizes of our riffle gravel and our spawning gravel were also scaled according to that Froude scaling. And because those are a length scale, it's your diameter of your particle, it's just a 1-to-1. So I wanted to note that our spawning gravel, we scaled the entire distribution. So we took the distribution they were planning to use in the field and we scaled all of the different sizes down. This is just showing the D50 of that. So how did we actually recreate and build this model? There's been a lot of different ways people do this. People have carved out streams out of wood. They've made it out of sand and then sprayed it with adhesive material. We decided to try out a relatively new technique that hasn't been used much in the past. We actually built our model out of construction foam, so insulation boards. So these are waterproof, they're relatively inexpensive, and they're really easy to carve and to manipulate. So we did this using a CNC machine, and I'll show a few pictures of what that looked like. So we took foam boards, glued them together we needed to, and then we gave the CNC machine the AutoCAD surface that was scaled, and it carved out an exact replica. I just wanted to put this here to show how relatively inexpensive these projects are in terms of research costs. So going out in the field and taking a lot of these similar measurements would cost much more. So it's relatively an inexpensive project. The material that we used for the roughness was actually just landscaping stones. We went to a landscaping store and bought bags of material of that size. Whereas our spawning gravel scales down to sand. So in that case, we bought a mixture of sand that we had to sieve and remix together to follow that grain size distribution. So this is what the CNC process looked like. This is the AutoCAD surface of the design that was given to us directly from Stantec. We just scaled it down 1-to-30 and fed it into the CNC machine. And you can see that the machine carves it out slowly to follow that exact surface. We actually had to cut it into 5 segments to fit because we couldn't, you see the CNC machine's like a limited length, so we had to cut it into pieces and then glue them back together. It took a total of 3 days to carve out the whole model. So this is what the final surface looked like. You could see the CNC machine smooths it out at the end. You get a very nice smooth surface. Again, it's an exact replica of that AutoCAD surface that we had. And you'll notice we've left these kind of indents here. That was so that we could recreate those coarse riffles after. So this is what the channel looks like after we glued on our roughness material. So again, this material is scaled to what we see in the field, and we glued it on to represent that roughness. And this is what that showcase reach looks like, just to give an idea of how it compares to what it might look like in real life. So this is the setup of our model. This is our flume. We have a head tank. That's where the water gets pumped into before it flows into the channel. We controlled our flow by using a V-notch weir, which is placed right against the head tank. And then that flows into 2 sets of pipes. These 2 sets of pipes represent that steeper section plus the deep pool. So we've added roughness in there to represent those steps, and then into the pool, and then into our model. So the flume itself is set to 1.8%, which means we had to adjust the slopes of some of the other segments to get the slopes to match what we have in the field. These are our sections of our design. And then it flows into a sediment trap at the end, which we then collect any material that might fall out the end. So this is what it looks like. The V-notch weir is at the top here. It flows through the 2 pipes. And this is what it looks like with flow through it. Again, this is to compare to what we see in the showcase reach in real life. So to finalize our setup, we painted the channel bed blue. The reason we chose blue is because it has really high contrast with our sand. You can imagine if we're adding our sand to represent our spawning gravel, in this case, it'd be very hard to see where that spawning gravel is compared to the rough bed. So the blue color allows us to really get nice photos and be able to visually see where our sediment's moving. We've also constructed our riffles in between here, and we've added these targets. That's what we use to then stitch the images together. So we have a trolley system with a camera attached that we roll up and down the flume to take photos. We take 2 sets of photos, angling the camera at different angles, and that allows us to build 3D models of our final surface at the end. And this photo here is actually the downstream end. You can also see our sediment trap here, which is where any loose sediment collects, and we then collect it and weigh it at the end of the experiment. I'll show a little video of what it looks like. So this is a relatively low flow situation. We haven't cranked up the flow too high, but you can see that sediment moving through. So this was like our test run just to see if it worked. So how we conducted the experiments, as I mentioned, the goal was to look at different seeding strategies for the spawning gravel and how they evolved and reacted under different flows. So we tried 3 scenarios. We tried a high seed, so we seeded the sediment right below the riffle. We had a low seed experiment, seeding it at the bottom of the pool right before the next riffle. And then we had our full seed scenario where we seeded the entire length of the channel. The depth of the spawning gravel was set by the design. So whatever Stantec's design was for how deep they wanted the spawning gravel, that's what we scaled down and added to our channel. And then we tried these 4 different flow rates, a 2-year, 10-year, 50-year, and 100-year return flow. And then this is the scaled in liters per second, what our flow rates were. So for each flow rate, we did all 3 experiments. So a total of 12. So this is showing some preliminary results. I won't go through them in too much detail, but we have our high seed, low seed, full seed for each flow. This is the weight of sediment that is exported at the end of the flume. And you can see that it does make a difference where you seed the sediment. Obviously, the full seed exports more sediment because you have a lot of extra material. At the time this table was made, we hadn't finished the last 3. These have now been completed, so we have our full data set. This is showing an example of the types of data we collect other than just the weighted sediment at the end. This is our stitched together photo. In this case, flow is from the left to the right. We can see that this was a high seed condition, so the sediment was seeded just downstream of the riffles, but we can see how they've migrated up over time. And then we have our 3D topography as well. As I mentioned, we take photos from different angles of the camera that we can stitch together. What we mean by non-detrended and detrended is that the non-detrended includes the slope of the flume. So these targets are tied into real coordinates. So when you survey it, you get the slope of the flume itself. But if we subtract out the slope of the flume, we can actually see our riffles much more clearly. We can actually see some of the sandbars and measure their volume, for example, over time. So that's where we're at now. We've collected all our data. We have all the data stored. Our next step is to analyze the collected data. So we want to look at how much sediment is outputted, the initial and final sediment distribution. So where does the sediment accumulate and what do those those bars look like at the end? And then use the DEMs and sediment volumes in the channel to give us more information. We're also hoping to run some sediment transport models to look at if we can calibrate and recreate what we see in the flume. So final thoughts to wrap up. Part of this project, I think, is a great case study for the benefits of using scaled models to study restoration projects. They're relatively low cost and quick. So within a few weeks, you can have a model up and running. You can test the performance of a design under extreme events before it's placed in the field. And it's a great way to validate some hydraulic models at those high flows. I know that it's hard to collect data, or we have less data at really extreme high flows. So it's a way to get more information to validate models. And you can test novel designs without, having to actually put them and take risks of putting them in the field. You can test out different things in the flume. Obviously, there's limitations to this. Again, a model is a simplified version of reality, but it is a nice way to get a first kind of idea of how a design might perform. I think this project also showcases the benefits of industry academic partnerships. You can share costs. Again, you can test designs risk-free. And I think a really big part is also student training. Students get to work with some of these models. They get to work with AutoCAD. They get to look at restoration designs, how they're designed, and actually get some of that hands-on experience, which I think is also really great from a training perspective. And that's just a last photo or video showing how pretty our model is. So again, I wanted to thank my tax who funded this project, as well as Stantec, the University of Waterloo, and UBC, who've collaborated with us and let us share their space. So I'm happy to take questions or discussion at this time.
Dave, can I dive in?
Hi, Brad.
Hi, Ellie. Quick question for you. Maybe it's the next step in the analysis, but I guess I'm curious, do you have any sediment left in the system after you've run a high flow through? I mean, what percentage of what you've put in is lost? I mean,
Yeah,
it looked pretty
great
high on
question.
some of them, but I don't know how much you put in.
Yeah, great question. So it depends on the flow. So in the 2-year and 10-year flows, we still see a good amount of the sediment, or the majority, is retained. Once you start getting up to the 50, 100-year flow, depending on your seeding strategy, you may have sediment left or not. So we're finding that usually when we seed the sediment higher, so the high seed condition, we retain more of the sediment than in the low seed condition, for example. In the 100-year flow, I think in the low seed, almost all the sediment had washed out. The full seed, you usually retain a good amount, but then again, it becomes a cost thing, because then you're saying you have to seed your entire channel. So that would be more material. So
Ellie, can you give me a rough idea how many kilograms of sediment you put in, like basically in terms of comparing it? Like, is it in the 2-year, you're retaining 80-90% of it, or 40% of it?
In the 2-year, I think we're retaining, I would say, close to 90% of it.
Okay,
so
thank you.
very, very
So I was
high.
just trying to get a ballpark where we were on.
Yeah,
the
that's a
scales.
good idea. I should probably have that in the table as well. Yeah.
Okay, thank you.
Hey, Ellie, I have a question I have 2 questions actually
Sure.
related to the model setup. The first one is, there's the assumption of an immovable bed in this, with the idea of gluing down the roughness factor. So you're using the bed material as just roughness, but then you kind of discount the hiding factor associated with a slightly movable bed. So do you think that means that there'd be more or less sediment stored in the system? So do you think this is conservative in estimating the sediment spawning gravels that can be stored in the system, or you think it's kind of liberal in estimation based on how that section of the model's been set up?
Yeah, great question. So the Stantec model, based on their hydraulic analysis, that roughness should be immobile. So that material is sized to not move during even their modeled flows. So that's why we chose to go with an immobile bed. We thought it would simplify the model, and we took that assumption. But you're right. I mean, that's just on average, right? If you have high flows, you'd get some of that roughness material rolling and redistributing at least a little bit. In that case, I would assume you'd get more hiding effects in the field. So I would say I would expect a little bit more material to be retained than what the model predicts, would be my first guess at that.
Yeah, that would be my
Yeah.
first guess too, but I wanted to make sure that I wasn't looking at it the wrong way.
Yeah, there is the option to run mobile bed as well. But I guess with experiments, you want to start simple before you add different factors, because you want to see what's affecting what, right? So you could redo the set of experiment with a mobile bed and then see how your results change, and that would tell you something about your bed conditions as well. So
yeah, I think from a practical standpoint, you just say, hey, this is a research, and we feel like we're underestimating the capture of spawning gravel in here. And I think that's a good story to be told without having to understand it all right now.
Yeah.
So next question is, and this is, sorry for the people that don't care, but the Rouse scaling versus the fruit scaling that we have in these systems, generally we have a Rouse scaling when we have a high sediment, suspended sediment concentration load, and that of course has an effect on the bed material load as well.
Yeah.
And with the idea of having the sand size fraction that you have in your flume, I was wondering how you guys came to the assumption that you're going to scale based on a Froude number opposed to the Rouse number from there. If it was a simple just assumption, hey, we have to move forward and do something, or if there was something else that was considered in disregarding the Rouse number scaling.
Yeah, great question. So because the spawning gravel is expected to move as bed load, we wanted to scale our material to also move as mostly bed load. So again, because our shear stresses are conserved, most of our what is now sand, because it's been scaled down to sand, is still moving as bed load, and we don't have a lot of suspended load. That's why we chose to go that route. Obviously, in real life, you would have a suspended load as well on top of that, but we've sort of simplified it just to focus on the sand. You're right, though, that is a challenge of flume experiments in general, is if you scale too small, you start to get the problem that now your sand is too small and you're going to start getting different movement. So we did make sure that part of this deciding a 1:30 versus a 1:40, for example, scale was making sure that our sand particles were still large enough that they weren't going to be in suspension too much. So it's a bit of a playing around with that. I don't know if that answers your question.
Yeah, I think I'm kind of familiar with where you're going there. Is the wash load kind of discounted in the assumption? Are we kind of breaking up into two phases, suspended and bed material load, or were we trying to account for a wash load as well in the modeling?
No, so we didn't account for any wash load in the model. We were just focused mainly on the bed load, which we assumed that the spawning gravel would be mostly moving as. So again, a simplification, but there's nothing stopping you from, again, running more experiments where you add some wash load as well. We just, I guess, didn't focus on that in this set of experiments.
Yeah, no. And I think that's, at some point you have to make a practical decision to move forward. And I was just trying to figure out if there was a reason, a really good reason why you're like, hey, we can discount this here, or if it's just, hey, we need to practically discount it. So
I'd say it's more on the practical side. We also didn't have a lot of great data on what those loads would be in the field to then be able to recreate them. So it was more of a practical consideration for us.
Yeah, so spawning gravel, when doing bed material load transport and wash load transport and trying to account for both of them, we've always been surprised with how much of the spawning gravel is influenced by the particle size distribution and the rates of the wash load. So not even though sometimes the spawning gravels are primarily in your bed material load, the influence of that wash load, you kind of as Wilcox and Kennedy had mentioned before, has a significant influence on your competency and your capacity of your bed material load.
Absolutely. And there's
So
actually been a lot of that work and observation has come from flume experiments as well. I know there's been a lot of research into looking into that in detail in flumes. So it's definitely a real consideration, but
well,
it's a little bit practically difficult to incorporate.
no, this is a super cool study that you looked at, and and basically, I love the idea of kind of a fairly low cost effort to try to look at some big scale questions and distributions in there. So the questions aren't anything negative. It was just making sure that there wasn't something I was missing in understanding. So.
Well, the idea isn't that this would replace how designs are made and, all models that are run. It's just more of a complementary way to test out different things before they're actually placed out in the field. So it's a cool way to maybe test out some new designs or test some unanswered questions that you might have. So it's more of a complementary exercise to designing, I think. That can be helpful in certain situations.
Dave Woody has a question.
Good morning. Yes, great presentation. We have worked with Stantec, ironically, on another project over here in Charlotte, North Carolina with National Fish and Wildlife in the Goose Creek watershed, where we were doing basically bed loads as well. And we used a expandable geocell to help hold some of the smaller material in. Have you looked at alternative designs based on the Flume model and kind of going back and brainstorm some more?
So not yet. We're still in the preliminary phase of trying to summarize and understand sort of what we got in this set of experiments. So we haven't gotten as far as to brainstorming and switching up the design and trying out different things, if that makes sense.
Oh, yeah. And were you able to get any grants associated with this? Because this is pretty neat.
Yeah, so as I mentioned, here in Canada, we have a program called MyTax where the industry partners, so it can be a company like Stantec, or it can even be a non-for-profit or municipal government. So your partner can be anyone. They put in part of the funding and then the government matches part of the funding as well. So it's sort of a mixed grant. It's really nice because it actually is pretty low cost for the partner organization. They have to put in, like their contribution doesn't have to be that big, and then you get some funding from government as well. And that helps cover costs like paying students or paying for materials. All those things are sort of covered. So that's the funding that we've been working through, and it's worked out quite well for us.
And one last question. In the beginning, you said you were designing to the 200-year storm. Is that correct?
Yeah, that's what Stantec's design was. I think your question is going to be, why are our experiments only to the 100 year? Is that?
Yes.
Yeah.
Why do you design above a 100? Because it's so, it is a fluke to go above that. But even at that rate of storm, you can have significant damage. But 200 year, that's a cost factor involved, I would think. Yeah,
I'm going to be honest. I don't know the policies and rules in British Columbia. Brad might know a little bit better if they're required to design to the 200 year, or if that was just a choice that Stantec made.
That was a requirement by the municipality, and it was largely done to take account of climate change to some extent, was part of the reasoning behind it. Rather than throwing in, I think, a fudge factor for climate change, they just said bump it to the 200. So I think that's the origin of it, Elli.
Right. The reason we didn't model it in the lab is because we realized our flume had a limit of our pumping capability, and we weren't actually able to get flows that high. Yeah, or the pump in the flume needs to be replaced is the short answer, but we weren't able to actually get some of the higher flows. So we decided to stick with the 100-year that we knew we could control and have a steady flow than to try to figure out how to fix the pump to get a 200-year flow. So that was, again, a practical limitation that we came across.
Very good. Thank you so much.
Yeah, I'd just like to throw in a comment about the low cost nature of this. Elli, would you like to share the cost of the flume with us so that we know what the real cost is?
Oh, yeah. So flumes themselves are very expensive. So flumes themselves will vary from 50 to 300,000 more, $500,000. But I meant low cost in the sense that many universities already have a flume. So the idea is that, you know, you wouldn't be buying your own flume for this. You'd be partnering with a university that already has an existing facility. So that's an important point there for sure.
Thanks.
All right. Well, thank you very much, Elli. We appreciate your time today and really appreciate you sharing with us.
Thanks, David.
Thanks, Elli.
All right. So to continue on for the rest of the time, we're going to use the inspirational time to talk about some ideas for river shared training in the future and share them with the group and get folks kind of a dream of where we think we may be going with river shared in the next year. So with that, I'll share this and move forward with that. All right. So as you have questions or something, feel free to stop me. It's pretty informal. And if it takes the time, great. If it doesn't, then that's okay too. All right. So what I calling this is river shared taking restoration to the world. And it's really just kind of meant to be a discussion this morning. You know, as I've been blessed to work on restoration projects for a fairly short career. You know, I've started about 20 years ago, 25 years ago, and a lot of people have been working longer than that. But it's very interesting to me that, you know, we have a nature-based restoration technique that we use that in a lot of places in the world, they have some of the same needs, but because of the way that it's packaged, they won't apply it because it's packaged as more of a, hey, let's talk about this after we have figured out a way to feed our people, after we've figured out a way to find work for folks. So one of the biggest things that I look at and kind of struggle with as we go into different locations and different opportunities is how do we meet some basic needs with what we call mitigation or what we call restoration in the US and Canada. And then how do we also create some sort of community and how do we build something around this so that we can kind of share with folks in different locations and then also learn from folks in different locations. A couple of weeks ago, I was in Ecuador with a friend, John Giardango, who's on the call about a month or two ago. And we were looking at the concept of what it means to build a community. And in this section of the high elevations in Ecuador, you know, you try to build community centers, but, you know, community that we came up with is really built around a common work. So when we talk about building community in small villages, a lot of times it's related to having a sustainable economy or a sustainable work or things that people are working together to try to achieve. So when we're looking at trying to create a new community and share some of the tools that we've been given with others, you know, there's questions that come up, you know, a lot of times we're like, hey, let's create a community. And what we're really creating is a celebration that can schedule an event, but we're not given a common work. So as I was in San Clemente, Ecuador, we're in a fishing village that, you know, has people that can't have a boat for fishing, therefore they don't have work. And then if you're talking to them about, hey, let's clean up shorelines. Let's do shoreline restoration. Let's do stream restoration coming into the inlets so that you have better production onto your fisheries. We can't really have that discussion until we talk about, hey, how can you have work at the end of the day? How's there something that we can kind of come together and have some sort of sustainable economy or solution related to that? So, this is a question that I think a lot of people have been struggling with in the ecosystem restoration community is, can we create a community that creates some sort of lasting change? And lasting change really comes by education and sharing ideas with others, opposed to us just saying, hey, we're going to do something that's going to be lasting. We need to really create a way of looking at problems with erosion, problems with the environment, fish passage, problems that we generally see as being sustainable into the economies and the communities that we travel to. And then how does education, how does a two-way education work? So as we're in these different locations, whether it's in Costa Rica, Sri Lanka, Ecuador, Uganda, as we go into these different locations, how is it that we can learn from the communities as well as share with the communities, opposed to saying, hey, we're going to go in there and fix all your problems? A lot of times we may not understand all the problems, but we may still be able to share a tool for them to learn how to use that tool to fix their own problems. So with this, a couple of concepts that we've been tossing around is this idea of a river shared institute, education and adventures. So years ago, a friend of mine talked about wanting to create a university for river restoration. And so you create a university system and then people would come through there. And the argument that he had at the time was that people aren't really getting trained well in doing river restoration. I slightly disagree with that in the sense that I think we have some really good universities, but as an industry, we need to start helping those universities produce the folks that are desired by the industry. So it's not really recreating a university, it's just creating an institute that can work with universities and can work with a continuing education alongside of universities and alongside of the industry. So, what I would say is, knowledge without adventure is kind of boring a lot of times. So we just learn a whole lot of things, but we never have the adventure of applying it. It's kind of a boring life. It's, we're like, hey, look, we know this, but we've never really applied it. An adventure without knowledge is kind of stupid. That's like, being like, hey, I'm going to go out there and take my truck in a mud hole and not know that the mud hole is going to sink my truck. And that's just kind of stupid. So what we're trying to do with this dream of river shared institutes is kind of start education with adventure and then start adventures with education. So it's kind of a twofold idea. So the first one is essentially working on 6 to 8 weeks of semester training broken up into 2 weeks of camps that can kind of come alongside of universities or come alongside of industries or professional. So it can be a professional certification, but it can also come alongside of different universities so that in 2 weeks we can offer up to 15 or 16 credits in a 2-week period, or as little as 2 or 3 credits if people don't want to take that many courses. But it would be something where it's a lot more active course. People would come into a setting and it would be a camp setting, it would be a university setting, or it becomes some sort of a compound where we'd say, hey, we're going to spend 2 weeks here and we're going to really get people to come in and invest and share their experiences with others and get people that are participating to be able to have a choice of course schedule. So if you say, hey, I don't really want to get 15 credit hours in 2 weeks because I'm not going to be able to stay awake and concentrate on everything, then you can say, hey, I'm going to go for a 6 credit hour 2-week period where I'm going to focus on just these classes. And then we also want to create, one of the biggest criticisms that we've had for training courses in the past is that some of the really valuable training courses in the industry have no test out. So you take a course that's called Introduction to Fluvial Geomorphology, and you may have a graduate level degree in fluvial geomorphology, but you can't test out of this based on your previous knowledge. You have to take the course. So that's some of the adventures that we're looking at. It's really supposed to be this thing that's a little bit more like a university in choice of taking classes and the ability of kind of testing through a class. Then another idea is kind of online, recording field sessions when we're doing the in-person training, so that people that can't travel to wherever we're doing the course can still get some value out of it with a reduced credit availability for it. And then continuing education from questions from Monday morning calls and other courses that we've had. So basically using folks to go through and kind of set a couple questions up. And if people want to take a half hour during a lunch break, listen to the continuing education Monday morning call, answer a couple questions, and they can get a professional continuing education credits associated with that. And Paula has been starting that process for us with 3 years of Monday morning calls. So we want this to be something that is industry reviewed and kind of sponsored by the industry, opposed to saying it's something that is just kind of educational. And as Elli had said, the idea, the value that you get from teaming with industry and the university is so beneficial. So if we can get to a point where we're creating industry review and sponsorship for education, I think that's going to add to the value of the universities that are joining us in this effort, as well as add to the industry. So instructors, leaders, and other nonprofit organizations, we see that this instruction will be very field-based and hands-oriented, and there'll be projects from nonprofit organizations, whether they're humanitarian organizations, whether they're nonprofit like Ducks Unlimited, Trout Unlimited, or whether it's a traditional faith-based missional organization where they have issues in other locations. These are all things that we're kind of looking at teaming with the instructors and leaders to create real-time projects for our classes and for instruction. So the next idea of this example of education with adventures is just going to give you an example of what the first session of a semester would look like. And this would be a 2-week-long course. We have one that we're tentatively looking to schedule for June 4th through 16th. We're going to probably not try to overly advertise it this time because it will be kind of the guinea pig run. So we'll invite some people, and obviously if somebody finds out about it and wants to attend, we'll allow them to attend, but we don't want to send out the advertisement the first year and then have a whole bunch of people say, well, that was kind of awful. We want people that will come in and say, well, that was kind of awful, but you can make it better this way, and this way. So we're looking at kind of teaming with people that are okay with being a guinea pig for the first session. And what we're looking at is you can take course offerings as high as 16.5 credit hours and as little as 1 credit hour in a 2-week period. And a couple of the courses, 3 of the courses that I'm giving you an example of, and I'll show you a schedule on the next slide, would be Introduction to Fluvial Geomorphology and River Assessment. And that'd be a 10-day course, about 60 hours. Introduction to Field Surveying with Lasers, Total Stations, and GPS. That'd be a 4-day course. And then Introduction to AutoCAD for Fluvial Geomorphology and River Assessment. And that would be a 10-day course, but only over certain times of the day. So we'd be doing that during hours that, or generally we can't do field activities on. So that'd be in the evenings. And you test out if you need to test out of those classes. So what this could look like is in the top, the rainbow schedule is kind of the different times that we have in the day, in a given day. And then I zoomed it into just kind of the days, the June 4th, 5th, 6th, and 7th. And this would be where we would set up different training courses. So for example, if you said, hey, I don't really want to do a basic surveying course, I want to take a riparian biology course or an aquatics course, then you can take a riparian biology course or an aquatics course and sign up for one course instead of the other course. Some courses will be concurrent, other sections will not be concurrent. But the idea would be is that we would stay in a place where you could tailor the schedule for your own activities. Some of these classes would be kind of the same coursework at the same time. So for example, 5 to 7, there'd be probably an hour where riparian biology and fluvial geomorphology is a shared course, because we're talking about the effects of riparian biology on fluvial geomorphology. You'd have 10 to 8 to 10 where you'd probably have a shared course between aquatics, being macroinvertebrates, and fisheries, and fluvial geomorphology, because we're talking about purpose and we're talking about the processes that drive restoration. So that's the concept or the dream that we're looking at. We know that this is going to be kind of something that's brand new to the industry. It builds off of things that we've learned from others. It creates some of the concepts that we've had others share with us in the past, but it's to a different level of detail and to a different level of vision and opportunity than what we've done before. We are not looking at keeping this as being hey, we need to do natural channel design. Hey, we need to do threshold channel design. Hey, we need to do beaver dam analogs. Hey, we need to do low cost process-based low cost design. We're really just trying to say, hey, these are the concepts and these are tools in assessment. These are tools in riparian biology. These are tools in fisheries and benthos. And these are things that we can apply with additional tools that come down the road. So this first session is really all about assessment and the way that we view natural systems. And then as we continued on to session 2, it'd be more about how do we look at reference conditions? How do we look at opportunities? How do we look at goals and objectives in different ways? And then as we go to session 3, it'd be how do we get to design, and then session 4 would be design optimization. And we hit on the same subject matter. So the concept is that we would create something that would work alongside of universities and in conjunction with some universities, or maybe some universities in time that say, hey, we want to provide college credit for these classes. And there's going to be some sort of standard testing associated with it, or some sort of way that we can say this is pass fail, or this is a grade based class. And then there'll be other times where we're just looking at it for where we may have somebody that comes straight out of high school and says, hey, I want to learn how to do river restoration. So they take these courses, they learn how to do river restoration, and they're set up as a certification program as a technician doing river restoration. So we're looking at a lot of different ways of how we can take training to folks and how we can do it a little bit differently. So both the locations of where we do training courses, I think, is going to be flexible in the way that they may introduce us to different opportunities. We want to have a lot of instructors involved in these classes. So we're not looking at having one key instructor. I think probably a failure in this class would be if down the road somebody said, oh, that's an associate the last name of one instructor to these courses. We really want it to be something that, 10 years down the road, we say, hey, we're going to do river share training courses. And they're like, oh, river share, don't they work with NC State? Don't they work with McMaster? Don't they work with Penn State University? Don't they work with Rochester University? Don't they work with these? Oh, yeah, they river share. Don't they work with Stantec? Don't they work with Five Smooth Stones? Don't they work with AMAC? Don't they work with Interfluve? And the idea that river shared is just kind of this mediator to bring education to people in different locations. And in the future, I could see taking a course like this in a location. We have some opportunities that may come up in Sri Lanka, and I could see taking a course like this and saying, hey, let's teach a course in Sri Lanka. And it's not going to be tomorrow. It's going to have to take a while until we understand it. But what the boundary conditions are until we build up enough people that can help teach some of these sessions in a different location. But I see that we try to bring in instructors from local regions, and we also bring in some instructors that have more of a national presence. But even those national presence could be a virtual instructor opposed to having to be there in the field. We incorporate the opportunity for people to come back as a field instructor to help add and give back to River Shared in the training. So I see a lot of neat opportunities for how we can get a lot of people involved in sharing their experiences and their knowledge, opposed to having it be very limited. So, and then the next side of the River Shared Institute Education Adventures is essentially create an opportunity for adventure and to learn new cultures with folks related around ecosystem restoration opportunities globally. So this is basically a travel-based research and extension and education. So it's finding ways that we can do small training with folks local to a region and extend our understanding of certain systems, and then share with their community and learn their local cultures, their local understanding of vegetation. So for example, when we were down in Ecuador a couple of weeks ago, the local culture was talking to us about sig-sig, which is a reed type grass that's a native grass, deep rooted for bioengineering. Well, we can use that for kind of log pools, step pool, and vegetated design for water bars to allow for stabilization of roads and to divert flows away from a school that they're having problems with related to flooding. But we don't have any idea of what sig-sig is until we have the local community that can tell us a little bit about what sig-sig is as a vegetation. So an example is, like I said, the bioengineering riverbank stabilization in Costa Rica. We have a mission organization that does a training facility outside of Rio de Orso. They're looking for riverbank stabilization they can't afford to bring in a whole bunch of boulders. So we're looking at natural-based solutions to take a small group down there to help them do a natural-based solution, to organize equipment and to train people locally and why we're doing what we're doing, and then leave that education with them, and then have people also learn from that community and be able to see how people live in a different section of the world. I think is a very beneficial activity and adventure for folks in the River Shared industry, in the restoration industry, to look at globally. We're looking at infrastructure stabilization of dirt roads in Uganda using nature-based solutions, and working with a small orphanage on trying to do civil engineering technology ideas for roadway drainage and waterway drainage, where it gives them a little bit of hope related to what they can do in the future, opposed to being branded an orphan and being kind of stuck as an orphan their entire life. Gives them a step out. And through that one we're looking to teach kids how to do AutoCAD for basically basic civil engineering technology ideas. And we have some connections with an NGO there that is closely connected to the Ugandan government. So being able to produce kids that can use AutoCAD to design a road, to design water bars for a road, to design roadway drainage, to design stabilization of waterways is a big need. And that's something that we can take to the world. Adaptive management of some of these projects. So maybe we have a project where we worked on in Ecuador and we did some bioengineering approaches. Well, in a year later, maybe part of the adventure is just taking a group of 4 or 5 people and just monitoring how is these bioengineering approaches dealing with, and then spending time with the community, whether it's a 2 or 3 day trip, that's it. So that's kind of what we're looking at, is basically this idea of taking education, having education with an adventure, and taking adventures with education. So with that, that's kind of what I wanted to share with you today, as some ideas, and open it up. If anybody has questions, comments, concerns, suggestions, I think we're ready to hear them.
Hey, David, thanks for sharing. I just wanted to point out that from a university perspective, I think this would be quite attractive. And I was thinking, especially with this Adventures with Education and Research, I think there could be opportunities to also partner up with some university research teams. And I know there's a big push. There's a lot of grants now for doing community-based research and that sort of things. There could be opportunities for turning some of these or leveraging some of these for funding as well from that angle too. It's just some spitballing, some ideas, but I know at least here in Canada, there are grants specifically for going to places and working with communities and sharing the work and doing some of that knowledge translation. So just wanted to share.
Yeah, I think that's a really neat idea. The limitations to my thoughts on these adventure and education and research type things has really been limited to kind of, a company that uses it as a retreat for their employees, or maybe a couple companies that kind of come together and have some high level people go in and say, hey, we want to learn about this, or doing it as a reward, but really being paid for by folks in the industry here as an adventure. But to be able to find some way that we can kind of team with others would be a neat opportunity too. One of the things that we've looked at with some friends in the past is the idea of, World Bank funding on some of these things. But in general, we're trying to do something that may be a little bit more of an adventure and less of a financial investment than World Bank would like. So, when you look at those things, you're like, well, there's people out there that may fund some of these things, but they're funding it for kind of a return on investment. But thank you for sharing that. It's exciting about where it could go. And we'll just kind of see where it goes. So. All right. Well, thank you very much, everybody. Have a wonderful week. And appreciate you being on the line, and we'll talk to you in 2 weeks. Thank you, Elli.
Bye, David. Thanks again.
Hey, Josh, are you still on? Hey, Brock, are you still on? All right. Have a great day, guys. Bye.
Yeah, I'm
Hey, you still there?
yeah, I was just looking at a map on the other screen.
Okay. I just
How
about
you
hung
doing?
up on you. So
Yeah, that's all right. No worries. Yeah, everything's going great, man. And let me know how I can help.
Yeah.
I don't really.
Yeah, I'm really excited about one of my big thoughts with the training course in the past is I've been blessed to be somebody that's been able to help with a lot of training courses in different places.
Yeah.
And I know that that's a very unique opportunity to be able to help out with these courses. There's a lot more people that want to help out with the courses than they're ever allowed to.
Yeah.
And man, I see this opportunity where I think we can take advantage of people that want to be sharing information with others. And I think we can do it in a very creative way, because I think there's a lot more to be said from the community than what we give the community time to communicate.
Yeah, I hear you. Yeah, I don't know what special thing I could do, but what I don't know, I could learn if you need somebody to present something. I've been doing stream work for 24 years. So.
Well, I think very simply is it's as we do these things, we're going to need field instructors. And then as we have field instructors that come out and help out with things, then we say, oh, okay, well, that field instructor comes out, and then we start to learn, hey, what do they have that's very unique that they can share with the group? And a lot of times the field instructors will start to realize what they have that's unique that can share with the group. But what I found out is, you're in the field for 20 years. There's something that's pretty unique that you do, even if you don't understand it.
Yeah, it's kind of like my uncle said. It was kind of like, he's like, even the cake taster gets tired of his job. I'm not that this is kind of mentality. Not that I'm tired of my job, but I don't realize, like you said, sometimes you do it for so long, you don't realize what you do have in your pocket.
Yeah, some of the simple tools that we do, we forget how unique they were when we started doing them. I've been teaching AutoCAD for stream restoration since 2002, and I forget where I was when I started. So often as I'm teaching new people. So some of the wonderment and excitement of, and when I learn something, I'll be like, oh yeah, just do it this way. And I kind of forget, oh no, that was actually a really big deal. When we figured that out.
Right. Right. I could probably use a course because I haven't done AutoCAD for, it's been 5 years now. So I could definitely use it, kind of just catch up with the industry where it is today as far as stream design. I'm sure it's changed a bunch.
Well, one of the things I think is really cool about this is we've been, you're familiar with Dave Roskin, of course, right?
Yes, sir.
So years ago, I went to work for Dave, and I worked for Dave for about 6 months and figured that's about it. That's all the more I could work for Dave. But the purpose of what I was supposed to do at the time was I was going to start to take over some training courses and give Dave a little bit of a relief and help his son learn how to teach things and stuff like that. So that was kind of the concept of what we had wanted to do. And then since I stopped working for him in 2008, I really didn't want to kind of cut in on the training courses that he does. He does an amazing job. He does a great job. And, I care for the family dearly, and he's given so much to the community. But this year I had a talk with him, and, he had shared how tired he's getting. And basically I'm still teaching courses. I guess people still want to take the courses. And so this year we're trying something a little bit different. Up until from 2008 until last year, all that we did was AutoCAD courses for stream restoration, and we teach aspects of stream restoration and assessment, but we didn't actually do Fluvial geomorphology unless somebody were to contact me, like Stantec. I taught a bunch of people when I used to work at Stantec how to do Fluvial geomorphology work, and I taught some people at Res because we had a big project with Res, and so we taught some people there, but it was never something we advertised. So this is really the first time we're advertising a different style of courses than just AutoCAD. And one of the things that I'm really excited about is that in the past, we always get some folks that take an AutoCAD course and they want to take it, and we don't have prerequisites. We allow anybody to get into it. But there's some people that, if we have a group of 15 or 20 people, you're going to have about 2 or 3 people that are like, why am I taking this course? At the end of it. And what I really like about this schedule is if you get to that point, jump over into another course. Right. If you're like, I'm not going to do this AutoCAD, well, then go over and do a regulatory course. Go over and do a course in riparian biology, do a fisheries course. And as long as we have enough options, then people aren't kind of stuck an entire week where they sign up for a course and they just can't kind of, it's just not how they're wired. Yeah. And for me, it's never worked. When I started Stantec, we had people argue with me. Well, actually not when I started, but a couple of years after I started Stantec, we bought a company called FMSM, which was out of Louisville, Kentucky. And that's where George Athanasakis, Mike Adams, and Scott Peaton and others were at. Mm-hmm. And when they came on board, they argued that only engineers should be taught AutoCAD. So they argued that for a while. And what I realized quickly is that some of the people that really excelled at thinking outside the box in AutoCAD weren't engineers. Because engineers are generally trained to think pretty linearly. For an engineer to think that uniquely and kind of go outside of what they feel comfortable with, and as an undergraduate engineer in particular, you're taught to do. You're like, hey, I know how to do something, and you think you know how to do a whole bunch. So you're not quite as creative. So we've stopped requiring that people have certain abilities when they take our courses, with the idea that we've had some of our best people that take our courses were not people we would have chose. But this is cool because we get people into one location, you're there. And then if you need to migrate out and go to another class, then you're still going to learn something valuable and have a great week from it, or a great 2 weeks.
Right.
As opposed to being like, hey, I'm stuck and I don't want to learn AutoCAD. And one of the things that we're looking at doing is with the AutoCAD then too, is that there'll be a session for each AutoCAD day that when somebody learns it, there'll be a session at the end of the day where if somebody's like, I started learning AutoCAD, I can't learn it, I don't want to learn it, this is crappy, but I really want to know what can be done. At the end of each day, we'll have a little bit of a summary where you'll get a reduced credit hour to learn what can be done and what the AutoCAD people got through for that day. So for example, you'll be like, and the key is like, if you're like, hey guys, we really need to know what the cut fill is on each structure for our permit, you're going to know that, yeah, that's simple to do in AutoCAD, and you're not going to know exactly how to do it, but you'll know the right words to be able to tell somebody, hey, we need this done. So, and that's kind of what we're hoping to do. So it should be really exciting. The location that we're looking to do the training course at is a site that I have a pretty long experience of understanding the river systems on the site and the camp that we'll be doing the first training course at. So I've been connected to it since 1978. So that's a long time. We've been collected a lot of data over there, even before I started doing river restoration work for benthos and taxonomy and fish data and stuff. So water quality data. So I think it'll be a neat opportunity to do something a little bit different. And this year we're going to try to keep all of our class sizes to max out at 20 people. So we don't want 40 people in a class. We want 40 people at the training center, but we want 40 people spread out over 3 or 4 classes at a time, opposed to 40 people in one class. And that will make a little bit different feel for the classes. But it does mean that it's going to be a little bit more difficult because we want an instructor ratio of about a 4-to-1 instructor ratio. So our instructors, if we're going to be paying fair market value for each instructor, then the cost of the course would be so expensive. So we're really going to have to be teaming with people that have a passion for this, that want to be a part of this training, so that we can make this something that's affordable and then also make it something that's sustainable in the long term. So it's going to be a different model than a lot of the universities where it's really hard to get at. I mean, universities, I started in the extension service at NC State in 2002. And the issue with the universities training is that, about 45% of the profits and proceeds from a lot of the training has to go straight back to university administration.
Mm-hmm.
And then a lot of times don't account for the cost of the instructors in there because they already have an assignment somewhere else, but you usually only get 1 or 2 instructors.
Right.
What we're looking to do is get, and the reason we're doing 2-week periods instead of longer is that we think we can find friends of River Shared that would be willing to come in and invest 2 weeks for the adventure of being able to train people. And a lot of people we're looking at are folks that are retired. So they've been in the industry and they want to give back. Some of our folks are now wintering in Florida, but they would love the opportunity to come back up and share opportunities. So what we're looking at is getting younger people or people that say, I don't know what to give back, and have them do a lot of the field activities and then being mentored by folks that are retired from the industry but still want to give back to the industry. And I was like, what a cool opportunity. So we're excited. We'll see where it goes. It works. If not, then I guess that was a dumb idea, but we'll figure it out.
No, it's worth it. Definitely got merit. It's worth a shot. I wish anything I could do to help or keep up with what's going on. I guess just follow the website or something, or is it already on? Is it in the schedule?
Yeah, so I think probably what we'll do is we'll probably put it on the website, and we'll probably hide it a little bit on there. So it won't be that it's not noticeable. You'll be able to find it and click on it, and it'll be as an event. But we will. We're not going to send out like a mass email for it because our concern is that we really know that the first one's going to have some hiccups, and we want to
Sure.
have people that are okay with hiccups. And we've been blessed with having a group of people that we've been teaching for AutoCAD courses for the last 20 years that are repeat offenders. So our
Yeah.
thought is going to some of those repeat offender firms and saying, hey, we're trying something new. Are you willing to support us with this? And it may be a big mess up, but are you willing to support us anyways? And then they'll send a couple people, and that way we know that we can do it. But it will be under, it'll probably be under news on the Rivershare website. I think that's
Okay.
probably what we'll wind up putting it, and it'll just say, hey, here's a new idea of a session 1 training course. And right now what we're looking at, McMaster University and Elli are looking at being team and partners with us also, but they're looking at 2024.
Okay.
So we'd be looking at doing the session 1 training courses as part of field camps for the university. We have Rochester University, which is a small school out of Michigan that is willing to put credit associated with these classes like tomorrow. So they're very flexible because they're a small university, and they're willing to kind of come alongside and say, yeah, we can give you college credit towards this. And they can take these credits and then put it towards a Master's of Applied River Science degree.
Okay.
So because it's a small university, you don't have to do things the same way you do with a whole lot of other universities. And, the value of the degree is just as valuable as the piece of paper it's printed on, and people's expectations and reputation of that program. So the idea is that, if the industry is pushing this, one of the things that we're going to need, and if you're interested in this, I would love to have you be a part of it, is we're going to need an industrial professional accreditation committee. So essentially, this would be the committee that would look over and say, this is what we're teaching in these courses, and this is cool from the industry, or you know what, you guys are missing the boat. We don't really need to know how to use a laser level again. We need people to be taught how to use total stations and GPS units and flow meters, and they can use a laser level, but let's not have them collect the data that way. Let's have them analyze the data through Rivermorph or Mecklenburg spreadsheet, or let's have them analyze the data through AutoCAD or GIS, opposed to, drawing a field map
Right.
on a field book. So those, we're definitely going to need that.
Right on.
And basically our goal is that the industry is driving the educational components of this training, and that universities come alongside and enhance the educational components of this.
Cool. Yeah.
So a little bit different than standard education and outreach, which generally outreach and extension is driven by the university, opposed to driven by the industry. This one would be driven by the industry and enhanced by the universities.
Yeah, that's cool. Have you you talked much with the Virginia Tech out there with what's her name?
With Tess Wynn,
Tess,
Tess
yeah.
Thompson.
Thompson.
Yeah. I think Tess, we haven't talked a whole lot about this exact concept, but Tess was on my PhD committee years ago.
Okay.
And Tess is a close friend, and they're definitely looking for kind of ways to team. So I see Virginia Tech being a partner in this, and I see NC State being a partner in this down the road. I see Penn State being a partner in this, Colorado State, University of Wyoming. And I think we have a lot of universities that if we create a good field camp, I have a feeling that one of our first concerns is going to be trying to leave open positions for the industry to get into it, because I think after about 3 or 4 years of doing this, we'll have, if we have a training course in Michigan, you'll have a number of universities that are 5 hours away from Michigan that will allow it as a field camp for summer credits for the kids. And, to be able to get 16.5 credit hours now doesn't mean that they're all going to be the credit hours they need for a university degree. They may all be elective credit hours, but still to be able to get 16.5 credit hours in a 2-week period is a pretty neat opportunity for kids. And then get a lot of practical experience, build opportunities with the industry. And the goal is that we want the industry to be driving this, because, the kids are going to have to, people coming out of this, we want somebody to be able to take this class that just comes to a new like if I have an intern for the summer coming to my company, I want them to be able to sit through this class for 2 weeks, and everybody in the industry being like, that was the best 2-week investment I could have had for training my summer intern.
Right.
And that's what our goal is. And I know that it won't be for everybody, but that's our goal, is that we want that to be an opportunity. We've been blessed. We've been doing summer internships through Rivershared for 8 years now. So we have a whole group of summer interns that have this history and this thankfulness of the fact that they were able to run as an intern that now work for other companies. So some of our connections are just kind of working on those guys and saying, hey, let's keep on doing this, but at a different level for the next group of kids. But I do see this also being something where, you spend 40 years in a certain side of riparian biology, and now you want to learn about fluvial geomorphology. Well, you're probably not going to go back to school for it.
Right.
But you can take this course, and maybe you help teach the riparian biology side so you can learn geomorphology along the way.
Yeah.
And that would be super fun to do. So,
yeah, I got a couple students at William and Mary where I work with at the community garden here in town, and they're looking for stuff, just what you're talking about. Especially we actually just had that conversation Saturday about AutoCAD, and learning just the topics that you're talking about, just kind of an introduction.
Yeah.
And he's actually looking for an internship and or early entry level position. So if you know anything. Yeah,
well, we actually we don't advertise any of our internships through Five Smooth Stones Restoration, Rivershared, but we hire anybody that breathes. So we're pretty flexible with how we hire people. Sometimes we scare people away because we don't have set pay that we give somebody. We ask them how much they want to get paid. And that's tough for some kids, because they're like, well, what do you mean you don't have a set pay? Well, we don't, because if we ask you how much you want to get paid, then you can't really argue about not getting paid enough because you asked how much you want to get paid. But then we don't guarantee work as an internship. Our whole goal is to train folks and launch them into the industry and build them relationships so they go into the industry. So if they were to go work for us and they started in the summer, one of the first things they do is probably sit through this class, and then they'd work on a number of projects with us. And then in general, some of our interns are a lot longer, but in general, we try to keep interns for about 4 to 6 months and then have them build a relationship and hopefully push them out into the industry, and then continue to support them when they're in the industry as well. But that's kind of our idea. With that said, we have one intern that started with us in 2018, went to work for another company and then came back to us recently. So, you have a lot of different opportunities that we've been blessed to be in relationship with people. So we're not super flexible, but I do know that if you want to put them in contact with us, even if they're not interested in kind of working with us as an intern for some reason, there's a lot of folks looking for interns this summer. Based on where they want to go, you can share my contact, and then I can talk to them about where they want to go, and I can put them in contact with some of our friends in different locations where they want to be. Do you know William and Mary? Is that in Williamsburg, or where's that at?
Yeah, it's in Williamsburg. It's right in Colonial Williamsburg.
Yeah. So my biggest contacts that I have in that area is going to be kind of in consulting firms, which would be Res and Stantec. But I know both of them are hiring this summer. But Stantec's always going to be a little bit more difficult to get into. They're still they try to be pretty elite in hiring people. Pass them on to us and we'll see where it goes. But this would be a neat opportunity for a young person to kind of build connections and stuff too. So.
Yeah, it's awesome. Yeah, I appreciate the contact, and I'll shoot him an email. And
and are you in Williamsburg area, or where you at?
Yeah, I'm in Williamsburg. I've been here 18 years, going on 19.
Okay.
But my office is in Richmond, but it's it takes almost 50 minutes to get there. So I've been kind of working from home for a while. But that's I do a lot of field work too, so I kind of get out of the mandatory come for 3 days. That our new governor kind of pushed a change in the state government. Work from home plan. But anyway, it's been good. I've really enjoyed it down here. It's home now. Seen a lot of creeks. I know that.
I had remembered you being in Richmond for some reason. So, but I guess
Yeah.
you always lived in Williamsburg and you just work out of Richmond. Is that it?
Yeah, I
Yep.
get it. I went there. I actually drove back and forth for about 2 years, and then just it was, it didn't really make sense. I could do everything I needed to at the house because I helped 3 different programs at the state with stream restoration stuff. So I kind of get bounced around. So a lot of it's just review and oversight type stuff, and answer a lot of questions. But so
Yeah.
it's worked out well.
I'll tell
We
you.
were actually trying to work on a nonprofit for the state, the streams like Maryland's got.
Yeah.
Kip Mumal and well, Tess said she had some time too, so we're going to try to get that off the ground this summer.
That's cool. That's cool. Yeah, no, I think we have one of the things that really gives me a lot of passion is in the industry, kind of creating a sense of community in the industry.
Yeah.
And I think we have some amazing tools that we can share with others, and we spend a lot of time arguing about which tool is the most amazing sometimes, opposed to just being excited about the fact that we have so many amazing tools to be choosing from.
Yeah, no, I like that. Yeah, I hear you. That's
And
cool.
we go to, like I said, a couple of weeks ago I was in Ecuador, and you drive around and you realize the knowledge that we've been given related to things that can solve some simple problems there is not common everywhere. And it's difficult to learn. It's just not common. It's just not institutional. It's not something that's been passed down. So I see that as being a neat opportunity for us to say, hey, let's just share this with people as we have the opportunity. And then, from us, we spent the last evening where they basically sang and did a celebration and a festival and a feast for us, which was a feast for them. And of course that, for us, we're like, oh, well, this isn't really what I'm used to eating and stuff like that.
Mhm.
But you learn so much by sharing with a culture and having people be able to share love with you, opposed to just sharing your knowledge and love with other people. So that's where the adventures kind of come in. And I see that as being a big deal in the industry, because, you get a lot of people that kind of get to a point in their career and they're like, okay, what's next? How am I really sharing with others? And this neat practical way to be able to kind of work together to build a community.
Yeah, that's a big driver for our nonprofit in Virginia, is getting just kind of everybody doing, not trying to do what you're doing, but just similar aspect, just kind of getting the people that are in our area talking and not,
Oh yeah. No, and actually, what we want to do as River Share is we don't want to be the nonprofit. We want to be teaming the nonprofits in regions. So like in the future, if we did a training course in Virginia, well, we'd want to be promoting the local nonprofits there in Virginia. We don't want to be saying, oh yeah, this is it. And hopefully what we have been able to do to date, and I don't know that it's going to be able to be the case, because to date we've limited our instructors because it's just based on AutoCAD, and then we do other things from the view of AutoCAD. But what we've been able to do for date is we have suggested donations for courses, and there's always been excess. So we've always been able to, at the end of the course, ask the people in the course where they wanted to send the donations to of the remaining funds for the course.
That's
so
cool.
we've been able to work with some pretty amazing groups. Camp K, which is a camp for kids with cancer, whose parents have cancer actually. And then they all do it. We worked with Water Missions International right after the big hurricane that hit Puerto Rico. We've worked with Cherish Uganda. We've worked with Engineers Without Borders. We've worked with EMI. And we've always been able to kind of give back through these training courses. And I think when we can truly do work and give back to others, that just helps build a sense of community even more. So that's a hope we have, and I see that with the local nonprofits as being a great way to do that. So.
Right on. Well, cool, man. Well, once we start working through the weeds of it, maybe I'll shoot you a call or something, see if we talk through, to get your ideas, see what you think.
Hey, that sounds cool. Hey, thanks a lot, Brock. Have a great day.
Yeah, buddy. You too. Stay in touch.
Yep. Bye.
All right, bye.